Look at this question in this video, and here's a case of a bullet of mass 20 grams that is fired such that it's initially moving with a speed of 200 meters per second. Oh, that's a large speed, and there's enough to cause some harm or damage to a human being if peradventure it hits somebody. Okay, this bullet is moving like that, and it strikes a block. Here's my block of mass 2 kg, initially at rest, hanging, suspended from this support. And then we are told that this bullet becomes embedded, penetrated the block, and both block and bullet now move. You can see how they move. This is the initial position of the block, and then after the impact, this is the bullet in the block. Both of them rise to this level or to this new position, each meters or each above the ground. If you understand the environment of this question, it's taken from the momentum and collision, and both are conserved. Energy is conserved, that is the total energy of the bullet and the block before and after the impact, and also the total momentum of the block and the bullet before and after the impact are also it's also conserved. So how do we use the ideas of energy conservation and momentum conservation to calculate the speed of both block and bullet as they begin to move off together after the impact? And then how do you find the value of H? Okay, that is the change in the position of the block and the bullet after the impact. Okay, let's first of all start by using the ideas of momentum conservation. That's total momentum, the momentum of the bullet plus that of the block before the impact is equal to momentum of that is V1, final momentum of the bullet plus the final momentum of the block after the impact. Okay, so initially we see here that the block is at rest, so its initial momentum is 0. So we are left here with M1V1 is equal to M1V1 plus M2V2. And after the impact, we also see that their final velocity is the same. That is, they move off together with a common velocity. You see, that common velocity, let's call that V, with which they begin to move together. It means that the final velocity of the bullet is the same as the final velocity of the block, and that is equal to V. So I can write here M1U1 is equal to MV plus, that is M1V plus M2V. Okay, make my substitution here. M1 here is 20 grams. I'm going to change it to kilogram. That gives me 0.02 kilogram. And then the initial velocity of the bullet is 200 meters per second. Okay, so I'm going to make my substitution. And the mass of the, let's call that M2, mass of the block is 2 kilogram. Already in SI unit, so we don't have any problem with that. Okay, so I'll make my substitution in this equation. So I have 0.02 kilogram times 200 is equal to my V is common into 2 kilogram plus 0.02. Okay, so this gives me this times this gives me 4.0 is equal to, this is 2.02 times speed. So their common speed or velocity, therefore, dividing both sides by 2.02 give me 4.0 divided by 2.02. This will give me 1.98 meters per second. All right. So it means that both bullets and block, after the impact, they start moving together with a velocity of 1.98 meters per second. Now, the next question, we're looking at the value of H. How high did both of them rise above this level after the impact? Okay, we're going to use the ideas of energy conservation here. Recall that at the point where at the moment the bullet strikes the block, both of them starts moving together. In the course of moving from this level, probably to this level, both of them have Ke. So when both of them rise to their highest point above the ground, we want to find this height H. Okay, let's see this height was before. We want to find the height risen by the two of them above the ground. It means the entire Ke of the block and bullet as they begin to rise together is changed to their Pe when both of them stop rising, because they must rise to a highest point and stop there momentarily before probably the block and bullet fall back to the original position. So as they begin to rise, what is their Ke? So say KE of block and bullet as they begin to rise. That gives me half m. The two bodies are now like one. So I can say that's the total mass times the speed. Now this speed or v squared is the speed of the bullet and the block as they begin to rise, through the through each. Okay, so that will be equal to the gain, because that becomes gain in potential energy of both masses, that is both bullet and block, and that is given by m1 plus m2 times g times h. So I'm going to take my g as 10 to simplify my calculations. Okay, now we put the two energies. That gives me half m1 plus m2 times v squared equals m1 plus m2 times g times h. That gives me half into mass of the m1 is the mass of the bullet, so it is 0.02 plus 2 kg mass of the block times 1.98 squared is equal to the sum of their masses again. This is 0.02 plus 2 times 10 times h. Okay, we have into this is 2.02 times 1.98 squared is equal to, this is 2.02 times 10 times h. Okay, so when I simplify this cancel, this gives me 1.01. So I'm going to have h is equal to 1.01 times 1.98 squared divided by 2.02 times 10. That gives me 20.2. Alright, so I'm going to evaluate this very quickly with my calculator. Both of them rise through a height of 20 meters above base level.